Now, without further ado, let me just introduce you to our speaker for today, Mika Nishiya. So Mika is a head of data at Adyen, the payments platform of choice for the world's leading companies, delivering frictionless payments across online, mobile, and in-store channels. She is responsible for overseeing data strategy, product analytics, and experimentation to help all merchants on their platform. And if she's not digging into data, you will find her at the nearest beach, hanging out with her dog, Hannah, and her partner. So it's over to you, Mika. Please take it over.
Awesome. Okay, I'll steal your screen away. Let's see. Boom. Well, I am extremely excited to be here. I think Woman Who Code's been there from, I would say, almost the beginning of my career. And I think I've enjoyed every single talk and event I've been to. So hopefully this will be possible in person one of these days. But until then, hopefully I can give you some insight into what actually happens throughout the day-to-day and how people can use data science, whether they're in retail and payments, no matter what the industry there it is. So a little bit of a kickoff, I think. Thanks for the earlier introduction. I'm going to go a little further in. My pronoun is she, hers. I was born in Japan, Tokyo, but I grew up most of the time in LA. So I saw someone that was already from there as well. I still say the 10 instead of just saying 10 for freeway. That's a picture of my dog Hannah and my partner. We live in South City. We're kind of they kind of help me make sure that, you know, take life as is and enjoy the journey. So I appreciate them, and they are a big part of my life. I'm a big fan of sports. Warriors was got me really into it, but I think it wouldn't be fair if I didn't mention WNBA or the NWSL, because I think they're doing amazing things. Outside of just day-to-day, I'm a big fan of K-pop. I'm going to a TWICE concert in 2 weeks, so I'm excited about that. I also like to read quite a bit. Prior to Adyen, I was at Verifone doing similar thing, but more around risk analytics and making sure that good customers were going through and bad customers weren't. And then now fast forward to Adyen. This is my 6th year, and I'll mention a little more about it later on, but it's been a great journey. As mentioned earlier, our team is focusing on data strategy, experimentation, partnering with our strategic merchants, as well as making sure that our product offering from a scoping to implementation to continuous optimization, we're being involved there. So I mentioned a little bit about Adyen, but for those that don't know who Adyen is, we are a payments company. So we kind of, when you hear payments, you don't think tech, but we like to think that we are in financial tech space, which modernize a payments platform and payments flow in general. A lot of the time it's very clunky. There's a lot of copying and pasting, connecting into different connections. And you can imagine from a data perspective, that's a nightmare. You don't get clean data. Well, you're doing a lot of transformation and trying to figure out what exactly happened there. So I think from a data perspective, I always like to talk about how clean it is from just our side, and seeing it from shopper user behavior all the way to performance and potential expansion on certain things. Been a pretty fun topic for me. Whenever we talk about Adyen, I think Adyen formula is a big one. This is kind of our motto that we work by. You can see it on our website, but I also like to highlight that this is exactly how I go to my day-to-day from a work perspective, as well as interactions like this. So really thinking about scale, doing good, and making sure that we're looping different people in to sharpen our ideas. So I am in the San Francisco office, but there are 24 global ones. So I think this is a picture of Sydney, which always, I have never been there yet, but hopefully in the future I can. Great. With that said, with a little bit of intro about myself, what Adyen is, and how that kind of, my interaction from a data perspective, I'm going to kind of go over the agenda and what to expect during the session today. So the why, I think, is very important in any kind of project, ideas that you're implementing and why data is the center and should be the center of the business. When we talk about framework, I think it's important when we are kind of scoping out how to do, let's say in this case, predicting the future or figuring out what's going to happen in the near future, what framework to go by. So you'll be able to digest that. I'll go over it and kind of summarize it at the very end. And then we'd have an actual execution of that idea into a time series case study. That's, I wouldn't say my day-to-day, but it'd be really cool if it was. And hopefully it'll be some interesting topic as well to cover. Again, if you have any questions, chat away. That's available for everyone to interact. And if you have any question or a question at the end, I'll be going through that later on as well. So now, why is data important? If you think about how businesses are making decisions, I think it was very common for people to make decisions without any insights when data was so expensive. It was so expensive to actually have a server. A lot of the things that were running on our machine, it's actually, we weren't able to do that, I would say, a decade or two ago. So I think before, it was definitely something that was nice to have, cherry on top, also very expensive, hard kind of to, I would say, make a case and prove it prior to it. But now with the hurdle of coming into it and trying things out a lot earlier, it actually has, I would say, a no-brainer to make sure that data is part of the strategy planning and then being proactive, right? What exactly has happened in the past? What has worked? What can we do differently? I think from an insight and strategy piece, very, very core to it. From a speed perspective, like I said, it used to take servers and servers, and now sometimes it only takes a machine or it's actually just in the cloud. I think the speed that we can actually make changes, whether that's from a model perspective or even a business decision, I would say it's a lot faster. And this kind of ties into the iteration piece, to be able to be, I would say 100% from the very beginning. I would say maybe you ended up taking too long to prepare for it if that's what actually the result was 100%. I think from an iteration perspective, it's really easy to launch and then kind of continue doing iteration. And from an impact perspective, for a business, I would say it's, again, a no-brainer. And are you, the questions that's really actually interesting to talk to a lot of the senior executive is to say, like, how are you leveraging data? What's actually important for you? And are we actually doing something about it? So for the framework, next step, I think when we're talking about any type of project when it comes to data, it kind of breaks into three pieces. I would say research, implementation, and then the storytelling piece. So for research, this kind of covers a wide range of things, but the biggest part really is, what does success look like at the end of the day? If you're doing something really, really shiny and cool, but the end, if the stakeholders aren't really understanding the impact, or perhaps it's actually a different direction that they wanted to go for, then a lot of time has been wasted. So understanding that and the why of what a project or a project is being kicked off for. Data collection is not the sexiest thing, and I think people don't talk about it as often, but it's important. If you have broken data, and then if you do really fancy things onto it, it's a broken decision or broken insight. So again, research, when you're actually doing any experimentation or looking for new ways of optimization, understand the fundamental data and the platform and the architects around it, and make sure that you have some at least testing in place that it's you can validate that it's up to date or it's correct. And hypothesis, right? I think when you're doing some kind of research, there's always all these ideas that come up. It could be coming from, hey, that's weird. It shouldn't be that way. Let's go investigate. Or, hey, that really works really well. What can we actually test out about that idea? I think there's multiple direction that you can go through from the research phase. But once you have a concrete idea of what you kind of want to test out, now we're talking implementation, right? I think what's really great about the data science and data area is that having a prototype and experimenting, again, I would say from a resource perspective, it's a lot easier than what it used to be. And then to be able to kind of compile all the insight and prediction, I think once something like that actually becomes successful, you want to be kind of graduating into perhaps a product feature or something that's more automated in sense of continuous improvement. But again, this is the implementation phase. Storytelling, I think it's underrated how effective storytelling has an impact on how your project kind of excels, right? At the end of the day, if you're doing amazing things but no one knows about it, I think that's a bummer, I would say, for the business and for the person that's committing a lot of time and effort on improving something for the business. So again, being clear, articulating what the key takeaway is, helping the stakeholder understand why what you're doing is really important. I think, again, a big aspect of how you can get this data project pushed off. So on to the case study. Let me check time. Okay, perfect. This example that I wanted to go through is a scenario where a shop owner is trying to figure out if they have enough money for their inventory next month. And I think this is actually a pretty common topic, right? It might not be just 1 month. Perhaps it's actually target ads and you want to see if what you estimated for your budget is accurate, or you're expecting to hit this many customers, but are you going to hit it, or was it something that again, you need to shift and iterate and change the direction of it. But I think what's commonly seen is to get this information and to be able to, let's say, collect historical data and to be able to predict what's going to happen in the future is, I think something that's intertwinably helpful and actually impactful for the business, and no matter what the industry is. So I mentioned the case study here for the shop owner, but again, I think asking the why is also extremely important because sometimes there is, even if stakeholder feels like this is the one thing that I need to understand, there's a lot more behind it that perhaps it's actually, there's a better question to ask to answer that question, or perhaps it's completely different, and that we have to go back to that whiteboard to understand what exactly we should be measuring. So the why, in this case, the shop owner is having limitation with the money flow. They don't want to sell out if they don't have enough inventory, and there's a lot of people coming in and they're trying to buy stuff. You want to make sure that the customer experience is positive and they have the inventory to do so. Thinking about going live with a new product, they could also be thinking, okay, instead of a drink, I want to go into acai bowls because they're so delicious. But with that comes money flow limitation. And so how do we actually kind of quantify and make sure the shop owner is prepared to be in that situation? Or perhaps they're trying to hire new staff because they have a lot more people. And if they're projecting to be having more and more customers or more orders being purchased, it might be a good time to hire more people into it. So these are the kind of scenarios that perhaps the customer or a business might be thinking through. But in any case, I think it's always important to, again, ask the why before you're going to tackle the project there. So before we kind of go into the code itself, I kind of wanted to do a high level talk on just Arima. I think it's actually great. A lot of people consider Arima to be a very classical stats model, but I think in this scenario, it actually works out really nicely. But I'll go through what AR, MA, and I stand for, but so for AR, it's a autoregressive future, pretty much saying what happened in the past will help us figure out what's going to happen in the future. MA, moving average, it's used to smooth out time series. And then I is a differencing part. So I'll go a little deeper into it later on, but you can see that depending on the trends or seasonality, we'll have to do more work to it. And then for our key kind of differences that we're going to talk through in the next slide, we have seasonal Arima. And so Arima is great if it doesn't have seasons. For trends, it's actually great, right? You kind of check the stationarity of it. You try to smooth it out, make sure there's no trends. But when it actually has seasons, it doesn't help it doesn't predict as well. So there's another one called seasonal Arima, which is great. And instead of just focusing on the PDQ for the trend aspect of things, there's also the seasonal piece as well. And so for folks that are interested in learning more, I actually have a couple of links that I can send you to that I think in books and just educational pieces that will do a more in-depth conversation around it. But for autoregressive, again, I mentioned it helped what happens yesterday. It will help us figure out what's going to happen in the future. Autocorrelation. Autocorrelation plot will actually is used to figure out what P ends up looking like, and then Q for the partial correlation as well. But what's really nice is that I'll show it to you in the code. There's in 2011 something magical happened, so hopefully that will actually make your lives even easier. And then the seasonal piece, again, the same aspect of it, autoregressive, differencing and average component, but for the seasonal piece instead of trends. Oh, and then I didn't mention this here, but this, I don't know if you can see my arrow, this little S stands for the what the seasonal trends are looking like. So you'll see here that since we're going to be looking at monthly data, it will be 12, but that's also another input that is required in the seasonal Arima. So now we're going to hop on over to the coding piece. Let's see, where are we here? Perfect. I'm hoping you can all see this slide right here. All right, so I'll share the code later on so you all can also work and play around with this too. I have the usual imports going through, some for visualization piece, some for stats models to make sure that we have access to some of the functions that are already available. And if you don't have some of these packages, again, you can do a pip install and install it from here in the Jupyter Notebook side. Actually, and then this will give me content, which I always like to see what's coming up next. But quick run through, I'll go through how to get the data, a little bit of exploratory data analysis. So in the beginning, you'll be able to see what's actually available, how to kind of slice and dice. I think in situations that you have a bit of a messy data, you end up spending a lot of time here. So a little bit of sneak peek there. We're going to separate out our data frame into a training data set, and then using some of it as a test sample to make sure that what we're kind of modeling ends up actually accurate to what actually ended up happening. And then we'll kind of move forward into the prediction piece. I already went through the stationarity part, but again, I'll kind of briefly kind of go through what the PQR means, and then some of the tests you can use to see what to kind of label them. Then we'll be kind of tackling the models, and then from a hyperparameter, we'll be tuning the hyperparameters. So we'll have, again, more functions that will let us optimize what exactly PQ and R should be. So that should be nice to see. Then we'll be fitting the model, which is a quick fun too. And then we'll be using that model to do this prediction here. And once we do a prediction, we'll validate the impact and then see how accurate it is, and then kind of take the last step of, okay, we got a great model to predict. Let's actually utilize and guess what the shop owner will be expecting next month. Are they in good shape? Are they not? Let's make sure we help out the business there. All right, so let's kick it off. I'll run this over. So we got them loaded. I got this data from Statista. I would show it to you all, but I think it only gave me 2 free clicks. So I was able to grab the data. What I ended up doing here is renaming giving it a column name, made sure that the month is indexed, and then it's actually a date time kind of formatting for that specific index. In a situation that, let's say, it's not a typable sample, and you have millions and millions of rows, you can always use Pandas to read the CSV. This is an example piece that I just grabbed from WNBA. Again, my love for WNBA, that you can actually just ping a site and then give you a data frame there. So this is an example. We're gonna forget about WNBA for a bit and go back to the orders that this drink shop owner is getting. So great, we have DF here. Let's see what it actually compiles of. Looks like there's 53 entries. The count, there's a column called count items. And again, we indexed it on month. So that's another column we have as well. So let's look at the first couple of them. We have hits here. Again, month, count items. And here in this situation, we actually created the data frame. So we know that there isn't any null, but again, it's important to make sure that if you do have any nulls, then I think the best approach is to average it out. If it's something that is very minimal, some people drop it, but that also has an impact. So again, this could potentially be another complete session, but let's make sure that there are no null values in the data frame. It's always great to kind of grab and describe and just give high level understanding of what actually is there from the math perspective. And then great, let's visualize it. Here is the drink sales by month. You see here that there is seasonality happening. I think every December there's a bit more sales going on, and it's a bit of an upward kind of direction. And this is a, there you go, distribution plot that you can see. Just as a heads up, are there any weird anomalies happening? It looks like, it's pretty consistent there. Third piece, we are going to split out the data. I think sometimes, depending on how big it is, people take the approach of 80-20, or perhaps enough data to grab a full, I would say if you're using seasonal Arima, you want to get at least 3 seasons, 3 round season, full seasons worth of data. If you don't, it's okay. It's not going to be as accurate, but again, it wouldn't invalidate your model. It's just that for best practice, if you do have access to that much more data, try to go back as much as possible in the historical side. In this case, I have it split. So the training data ends on December, and then the test data starts in January. So here's the head of test data, 1, 2, 3, 4, 5. So we starting in January. We have enough data for 5 months. 5 months to be able to kind of test it out of how our model is going to be kind of performing. So we talked about seasonal Arima and Arima, but what is stationary or being stationary? I think this is a common topic when we actually talk about Arima and seasonal Arima, but as the kind of, I think the text mentions, it's to make sure that there are no trends or seasonal variability. And in this case, there is definitely seasonal variability. There's definitely a trend. Sometimes it's not as easy to see with your bare eyes, but we can show you how you can actually see that from a math function perspective. And then back to in the situation that, let's say, there is a trend. no seasonality. In those situations, you can actually get rid of the trend. And Arima is great at after actually if the trend is removed and it's actually stationary. Arima is a great choice to kind of use that model to make those predictions. But in this case, we do have seasonality, so that's kind of out the door. And if you think about how to utilize Arima, it's kind of broken into 4 steps, which is let's first test for stationarity. If not, let's go make sure we difference until it is stationary. Then kind of use the fit to make sure to fit the method and model and to actually forecast, and then put back the trend. So in this situation for seasonal Arima, we wouldn't be going through this, but it's I also wanted to highlight what it would look like for an Arima case. And I think, I'm sure you've all seen this many times, the PDQ and the month side, but a little, again, just as a reminder, P stands for autoregressive, D is for integration, so differencing, and then Q, again, moving average. The lowercase is for the trend side, the uppercase is for the seasonality piece, and again, M, we have a number for the seasonal period. So let's look at, let's decompose this and see what it looks like for this specific data set that we had. In our eyes, it was actually easy to see the trend upwards, but you can actually have run this seasonal decompose, and you'll be able to see here that there's a trend going on. A trend going on here. The seasonality spikes here. And this is the original data frame that we had. And then this is the residual that you might be seeing. But here, again, you'll see it on month 12, 24, 36, where there are spikes happening. So what do you do when you actually can't tell from just looking at a graph? Well, don't worry, there's always something we can do from a math and coding perspective of how to figure that out. So this is a way to run augmented Dickey-Fuller test. This is a manual function, so you can actually see it here. The function itself takes the data frame and then looks, again, whether it runs the add failure here. And then it gives us the stats insight into test statistics and p-value lags, and then the number used observation. Whoops, my AirPod got stolen. So let me come back here. Hello. I'm hoping you can all hear me again. Perfect. So in this situation, we'll be able to run the function here. It gives us couple of really great data here, but let me run it so you can actually see it. Also very quick, which I love here. So again, test statistics, we get a p-value here. What's really great is if you look at the AIC, you actually see that if it's greater than 0.05, the p-value is greater than 0.05, then you can say that this data is not stationary. So you can actually test the null hypothesis and see if the sample here is actually stationary. And what's actually interesting, what I can do is show you this, what this kind of looks like. Yes. Where are we here? So if you were to just run this, it gives you just like numbers, right? I think, and what's really great about this function, it cleans it up and then lets you know exactly what you're looking at here. But hey, that actually takes work. What's great about just Python in general and any kind of coding environment, you can make your life easier. There's actually a function that you can run and it gives you a p-value. So if you ever want to do a unit test, unit root test, just call for this function, import it in, and then make sure you grab the training data and see, okay, what's the p-value to figure out if it's actually stationary or not. And again, p-value is greater than 5%, so you can say that it is not stationary. Now on to defining the model. I think this is exciting. We got the data, we looked at it, we analyzed it, we said it was in a good shape, and then we understand that there is a trend, there is seasonality. So we need to figure out what PQR, big PQR, and M actually ends up looking like. And I don't know if you've actually read a couple of the, actually there are lots of books around this, but until recently, 2017, I said 2011 earlier, but it's actually even more recent, 2017, this used to be a manual process. People would have to run loops and have split for every different combination. If you wanted to do it systematically, you can actually, again, look at this seasonal decompose image here and kind of guess what actually those steps or the PQ and R would be. But in a systematic way, it wasn't as easy as it was in R, because R always had auto Arima. But again, now that we have this, let's run the code. Test it out, and lets us know what's the optimal model we have here. So it tells us here 110, 011 with a seasonality of 12. And again, here AIC, I don't know if I don't know actually how to say this word, but AIC, you'll be able to, it's actually a great way to measure. The lower, the better on how accurate the model is. So this function was able to give us the most optimal one. It only took 5 seconds. Again, I've tried to do this on a loop before, and it takes a long time. So amazing that we have it as easily accessible. And then it's always fun to see the summary as well. The big thing to kind of look out for is really what the model looks like. It's kind of nice to see the observation, but again, the p-value being very small, I think is what's helpful on making sure that this model will be effective. Now let's move on to fitting the model. So now that we know PDQ and also the seasonal side of things as well, we'll be able to call out Zarreen here. You have your training data that we split earlier. DF was our main one. We split a handful of transaction into most of the transaction into the training data set. And then we have a handful in the test side. So once we make this prediction, we can validate. The second row we have here is the order here. Again, this 110 is coming from, whether you can see it from here or here. And then the seasonal order here, over here. Same over here as well. So let's run this and fit the model. Again, very quick. And then we'll be able to grab the prediction here that ended up running already here. And once we fit the model here, what we ended up doing is we are forecasting with the model that we have. I grabbed the test data set. So that was, again, I think just 5 months of data. You could also, what I ended up doing is just seeing how long that data set was. You could also do something similar to like that. But again, if you're replicating any data sets, these are always nice little functions to have here. So let's see what we ended up predicting. 5074, 5202. And you can see that we have a float in a month in a similar fashion. So actually really nice is I pulled out the test data right here. So you can see kind of same, kind of different. You can actually see it here on the next step of what the residual looks like. And then the absolute value as well there too. And I also have a graph. So I'll take a pause here. Maybe let me make sure that I kind of went through everything here. Prediction, maybe take some time here. What I ended up doing is I grabbed the prediction after running through the forecast. Residual, I wanted to see what the delta was, right? From what we said it would be to what the actual prediction was. And then you'll be able to get the residuals, the sum of that. And then you also have the error here, right here. In the actual graph, you'll be able to see the difference between the testing data set, training data set, the larger version, and then compared to the testing data set combined with the prediction side. So again, this is the original data that we had, and then this is the prediction piece. And so let's, that's kind of small. Let's zoom into the actual prediction versus the test side. You can see here that got pretty good on April and January. And I think there's a bit of a difference, but let's quantify that difference so we understand, like, is it very off? Is it bad or is it good? And root mean squared error is a great way of looking at this. It actually quantifies it in a way that it's easily translatable of what's actually happening, so that it's, again, easy to understand what the delta is and how far we are. So it looks like it's about 200 orders, 220 orders. Not too bad considering there are about 6,000 orders a month there. And again, I think we showed you this earlier, which is a mean absolute error, which is around 2.9%. So great, let's do some future prediction. So originally, the case study, the drink shop owner wanted to know if they had enough for next month. So let's make that prediction for the next month in the future. Let's pull this up. Again, visualize this, very similar to the graph earlier. We now have the original data, the prediction, but one extra month addition to what we originally had from the test data. So back to the question, did we actually, does a shop owner have enough? Will they have enough money to kind of stay afloat for the next month? They do. Let's go back to the presentation here. So time series forecasting, this wasn't specifically to, let's say, everyone's day-to-day, but I am hoping that it actually gave some insight into, again, volume fluctuation, people trying to predict the future and why they're trying to predict the future. And if you were to, let's say, replicate this in situations similar, so let's say as a framework and what you'll try to kind of tackle from a data perspective, first, you want to check if it's stationary. If it's not, you want to make sure that you're decomposing and you're making sure that the stationary is there. Once you do figure out what, again, those PDR stands for, then you want to make sure that you actually go into the fit and then seeing how the impact is there. And once you do, find the right fit, is able to forecast, let's go ahead into the future and make some prediction of what's actually happened, what could potentially be the case. And again, the measurement part, right, RMSE, I think, to make sure that we're validating that our model is effective and that it actually has we are saying truthfully of what's actually going to happen, and it's impactful. We can actually quantify that. So again, validate how effective that model is. So again, did the owner have enough for the next month? They did. Thank you. So that was part of my case study. Again, thanks for being here today. We'll move on to Q&A, but we are hiring. So if you are interested, feel free to visit our site. And if you have any questions or you want to connect, let me know you saw me at Women Who Code and connect with me on LinkedIn.
That's amazing, Mika. So in the chats also we can see people really enjoy the talk, and it was very like fluent. I mean, it was just flawless. So thanks so much for the talk. We have some questions in the Q&A section. So someone asked, what's your advice to convince companies that data and growing a data team is important?
Yeah, I think it's no matter what size of the company is, again, it's always so important to have these insight. But I think what a lot of people have a hard time understanding is like what the impact that the group can bring. And depending on, again, the phase of the company, it could mean, again, really fast prototyping of a product and it makes you go really fast. Or you take the, hey, if you don't, it's actually risky. And therefore we should have these kind of teams in place. But again, it comes down to what does the success look like for your senior executive and what they're looking for, and making sure that there's, within that conversation and story, you are part of it, and educate. Sometimes data comes off really scary. So if so, then let's make sure that we're again, the storytelling part, right? To make sure that the business understands the impact. And then lastly, I would say, let's say, the really great thing about data is, again, it's a lot cheaper now. We can do it on our computer with minimal, I would say, access. You could even do it with dummy data, or you can scrape some data, or ideally you have data within the company that you can collect. But I would say just do it. I think if you provide any insight that is helpful for the business, they'll see it immediately. And then because it's part of their day-to-day and it's important to them, I think it will be easier to have that conversation.
Amazing. So the next question is, what skills help someone to be a great data scientist?
Yeah, again, it's kind of funny because explainability is really, like, I think it's actually really big, right? When we can understand from a textbook perspective, from a coding perspective, but if people aren't able to process that, I think, again, it's not as effective. So I would say the explainability and the communication piece. Strategy, also extremely important. When we're also hiring, the common aspect of things is, we want to find people that can make sure that they can focus on needle moving projects, find these opportunities, because let's be honest here, there's a lot going on in life, right? Always. And then there's a laundry list of things we can do. So we have to be able to say no to a lot of things. And I think from a strategy perspective, to be able to prioritize and see the big picture of the vision and where to put your emphasis on as a data scientist, it almost exponentially, I would shoot the value of what that person is able to do.
Amazing. So basically, we should look out for problems, be a little creative and curious. And so, yeah, amazing tips. On that note, so someone asked, do you have any tips or advice for someone beginning their career in data science?
Yeah, I'd say start small. I think it's all. If you look at a lot of the project, it's big. It's overly complicated sometimes. I think just getting the momentum and trying things out will get you excited. It'll actually, it'll process better too from an idea perspective. And then I would say, don't do it alone. I think this community is great too, that you all have here. I think having a group of people to lean on to kind of, I don't know, sharpen your idea and talk through certain things, like that goes so much further than sitting in a corner reading a book for like 5 hours trying to understand this theory that I just read like 10 times over and over again. I just had like college memories coming back, but I think doing all this with a group is always great. And then lastly, I would say, don't underestimate what you can in one day. I think it's very small, but I think it's a very common thing for us to be like, in a year, I want a job, or in a year, I want to be able to do experimentation with these 10 different things. But if you actually break it down into smaller chunks, spend like 15 minutes, it's hard. I think in coding, it's actually better to do it in a longer period. But if you can, I think 15, 30 minutes every day goes a really long way.
Awesome. Next question is about how do you recommend finding a mentor in this field, or do you think I mean, how much impact it may have having a mentor?
Yeah, I'd say it's very impactful. I actually had an interesting, well, I would say like not the typical route for mentorship with a lot of my mentors. If I look at all the mentors that I have, I would say they're like, part-time, like they're not official, but when I need them, they're great there to like bounce ideas off of. But I would say, don't just focus on data either. I think if you think about data science, it works very closely with product. It also works closely with development. So having mentors in different areas, also very effective. And then back to your original question of like how, was it the question? How to look for mentors? I think these events are great, just randomly pinging people. When things are back in, I was going to say back in the office, but back in person, I think those networking events are so valuable because you're just hanging out, talking about, a topic, whether that was a conversation on the session or just random things, to be able to have that FaceTime. Like once you do that, I think a LinkedIn Connect is a lot more effective. And then don't be, I would say, shy on just sending an email too. Ideally, you can give them a call, but not everyone, you can't really find everyone's phone number. So even a simple personal email out, I think is definitely worth it.
Great. So probably here, if some attendees who are just trying to get started, so probably Women Who Code Data Science is a good place. Probably shoot us like a message in our Slack. Who knows, you may find a mentor or a study buddy to learn about data science. Amazing. Thanks so much, Mika. And we have the final question. It's about, is time series the most frequent form of analysis or modeling that you use in your work?
Time series is a big one, I would say. But it also, another aspect of it is really like categorizing too, of figuring out what actually has an impact, right? Like if you think about payments, there's so many different aspects of information we can send. So what's actually the correlation in those situations, in that specific scenario, when you're optimizing for a specific scenario or a payment message, or for in our world, we end up using something like multi-banded algorithm to figure out like what's the optimal kind of combination. So I would say that those two will be the most used those two will be most used. And then I would say from experimentation perspective, there's also A/B testing, right? That's the classic one to figure out from, in what situation or what version actually works the most effective.
Great. So I think that were all the questions we had today. So we are almost at the time as well. Probably we can call it a wrap. Do you have any final things to say to our attendees before we close in?
Well, thanks, Women Who Code, for having me here. It's been actually something that I always looked forward to. Hopefully we can do this in person, again, I mentioned earlier. And then for folks that's on now or listening to later on, I think this is a great community. Take advantage of it. There's a lot of, I think great people trying to learn and help each other. But enjoy the process. It can be painful sometimes. But I think at the end, if it's something that you're passionate about, keep on doing. I think the fact that you're watching this is already a lot. And so I hope nothing but best for the future and the impact that you are going to have. And then last pitch here, we are hiring like a lot of people. So if there's anything interesting in the career page, let me know, ping me. More than happy to tap.
Amazing. So thank you so much. From Women Who Code, we would also like to thank you for giving the fantastic talk to our community today. And thanks so much to our partner Adyen for organizing this, collaborating with us. And we hope to see you again in person or virtually, but definitely we would like to have you again here. So have a good day, everyone. Bye.